Hello everyone. In this video, we are going to study about filters, especially L-type filters and P-type filters. So let us start. First of all, we'll see what is filters. The electronic filter, it is a signal processing filter, and the main function of this filter is to allow the DC component of the load of the filter and block the AC component of the output of the rectifier. Therefore, the filter circuit output will be a stable DC voltage. The filter circuit can be done by using basic components like resistors, capacitors, and inductors. The inductors allow DC signals and the capacitors blocks the DC signal. Basically, the electronic filter removes unnecessary frequency components from the signal. The importance of a filter is to attain a ripple-free DC voltage. Basically, filters are efficient while eliminating or removing AC ripples from the rectifier's output voltage. So this is all about filters. Let us see L-type filter. This L filters or L-type filters consist of an inductor connected in series with rectifier output circuit and a capacitor connected in parallel with the load resistor. It is also called L-section filter because the inductor and capacitor are connected in the shape of inverted L. The output DC voltage from the rectifier circuit pass through the inductor or a choke coil. The inductor has low AC resistance and extremely high AC reactance. Thus, ripples get filtered through choke coil. Some of the residual ripples, if present in the filtered signals from inductor coil, will get bypassed through the capacitor. The reason behind this is that capacitor allows AC and blocks DC. Now let us see the working of this L filters. Here we have a circuit diagram for L-section filter, and it is very well observed inductor and capacitor. They are connected in inverted L shape. Okay. So at this point, this is the input point. Okay. And this is the output. When the DC signal from the output of the rectifier, most probably rectifier is connected to this point. So that DC signal from the rectifier is the input for this filter. The AC ripples present in the output DC voltage gets filtered by this choke coil present here. The inductor has the property to block AC and pass DC. The DC resistance of an inductor is low and AC impedance of inductor coil is high. Thus, the AC ripples get blocked by this inductor coil. Although the inductor efficiently removes AC ripples, a small percentage of AC ripples is still present in this circuit. These ripples are then removed by this capacitor connected. Okay, this is in parallel with the load resistance here. Okay, the two are in parallel. Now, the DC output signal is free from AC components, and this regulated DC can be used further. Okay, if this inductor of high inductive reactance, that is XL, greater than the capacitive reactance at ripple frequency is used, then the filtering efficiency get improved. Okay, and this is all about the working. Now let us see here how it works. It's shown in the graphical representation. We can observe this whole this curve. This is a rectified output. We might have connected a rectifier over here. It may be half wave, full wave, most probably full wave or bridge wave rectifier, whose output is this, indicated by this, which is connected to the filter. And this rectified output from the rectifier is then filtered by this LC filter, and the output across this RL, that is VL, will be this. Okay, so this is all about L section filter, and let us see how the output voltage can be measured. So here we can see output voltage of the rectifier is 2 by pi VL minus 4 by 3 pi VL cos 2 omega t. If the indicator's reactance is negligible as compared to load resistance, then see this VDC will be simply 2 by pi VL max. Means this whole term get disappear since the indicator reactance is negligible. Okay, and here if RC is the choke resistance, then this equation can be written as VDC is equal to 2 pi VL max minus IDC into RC. A filter is considered efficient if it removes ripples effectively. The ripple factor is the ratio of the AC present in the output signal and the DC. So, the most effective way to minimize this ripple factor is to increase the value of inductive reactance. And suppose we improve this value of inductive reactance, then our equation become IRMS is equal to 4 by 3 pi under root 2 VL max by XL, which is nothing but root 2 by 3 VDC by XL. Here AC voltage across the load is equal to the voltage across the capacitor. It is very clear from the figure we have drawn in the earlier slides. So this equation can be written in the form of V AC RMS is equal to I AC RMS into XC, which is nothing but root 2 by 3 VDC into XC by XL, where XC is nothing but 1 by 2 omega square C, that is the reactance of the capacitor, at the second harmony frequency. Now, this equation is used in terms of, now we can have ripple factor equation for the ripple factor, and ripple factor is denoted by gamma. We have already seen in the video of rectifiers, and it is given by gamma is equal to VAC/RMS by VDC. So this equation can be written as √2 by 3 into XC by XL, and when it is solved, it comes out to be √2 by 3, 1 by 2 omega C, 1 by 2 omega L, and that comes out to be 1 upon 6 omega square LC √2. Okay, this is, in this way we can, by substituting the value of L, C and omega, we can find out the ripple factor. These are some of the advantages and disadvantages of L section filters or L filters. It provides better voltage regulation. The ripple factor can be varied according to the need. And the disadvantages of L filters is its size is bulky and not suitable for low voltage power supplies. Let us study pi filters. A pi filter has a 2-port or 3-terminal, 3 elements, where each element includes 2 terminals. And the model of the circuit makes a symbol of pi. The elements used in the circuits are capacitor and 1 inductor. The pi filter circuit is designed with 2 filters capacitors. Since we are using 2 capacitors, we'll name it as C1 and C2. And a choke coil, that is inductor, it is indicated by L. These 3 components are arranged in such a manner that it forms a symbol of pi. It can be observed very well over here. Say this is C1 and this is C2 and this is L, that is the inductor, and this makes a symbol of pi. Here it is the input voltage. Here we are going to measure out the output voltage. Okay. So here C1 is connected across the output of the rectifier. Here we are going to connect, supposed to connect the output of the rectifier, and to this point, yes, our C1 is connected. L is connected in series, and C2, this C2 is connected across the load. One load resistance is to be connected over here. Okay, so we can how it works, that we'll see. The rectifier's output, which is going to be connected to C1, the first filter, this filter C1, provides small reactance towards AC component of the rectifier output, as it gives unlimited reactance towards the DC component. So capacitor C1 avoids a considerable amount of AC component, whereas the DC component maintain its journey towards the choke. Okay, so in short, what we can say is DC component moves towards the L. This choke L provides approximately or very small amount, or we can say zero reactance to the DC component and high reactance to the AC component. Therefore, this inductor allows the DC component to supply through it, whereas the unbiased AC components can be blocked. Then this another filter C2, another capacitor C2, avoids the AC and the component which the choke has unsuccessful to block. Thus, simply DC component shows across the load resistance. After this load resistance, when the output voltage is measured, we'll get simply DC component. Okay, so this is all about the working of the pi filters, and let us see how these characteristics are obtained when this filter works. This characteristics produces a high output voltage on small current drain. In this filter, the main filtering act can be achieved through the capacitor C1. The remaining AC ripples are filtered through the second capacitor and inductor coil. Okay. The high voltage can be attained at the output of the filter because the whole input voltage comes into wave across the input of C1 capacitor. The voltage drop across C2 capacitor and choke coil is very, very small. So since this, we can observe here the voltage drops across this L and C is very less. This is the voltage, output voltage from the rectifier, okay, which is the input for the filter, and maximum voltage is converted since there is very less drop across C and L. Therefore, the filtered output is this curve shows the filtered output, and the voltage drop is very, very less due to this L and C. Therefore, what we can say, the high voltage is attained at the output of the load resistance. See, here high voltage is attained at the output voltage across load resistance. So this is all about the characteristics in pi section filters. So let us see the output voltage in pi filters. Just now we have seen this pi filter offers high voltage gain. However, to the high output voltage, the pi filter voltage regulation is extremely poor. This is due to the decreased output voltage by the increase in the flow of current through the load. So, the voltage of the pi filter can be expressed as VR is equal to IDC by 2FC, where C is equal to C1 in pi filter. Then the RMS value of this output voltage is given by VAC RMS is equal to VR by pi root 2. And when we substitute the value of this VR, this VR we are going to substitute over here. So our equation become VAC RMS is equal to VR by pi root 2, which is nothing but 1 by pi root 2 into IDC upon 2FC1. We have simply written this C as C1. So this equation becomes simplified and it comes out to be IDC into XC1 into root 2, where XC1 is nothing but 1 by 2 omega C1, which is nothing but 1 by 4 pi FC1. Okay, this is in terms of frequency. So this is the equation at second harmonic distortion. Now, the ripple voltage can be attained by multiplying simply XC2 by XCL in the VAC RMS equation. So simply what we are going to do, we are going to multiply this VAC RMS value by XC2 into XC2 by XL. So simply substituting these values, this is IDC XC1 root 2 into XC2 by XL. So this is about VACRMS, and we know the formula for ripple factor. Ripple factor is gamma is equal to VACRMS by VDC. So simply we are going to substitute the value of VACRMS and VDC, and we'll get the equation as VXC1 VXC2 root 2 upon RL into XL. And when we simplify all these values, we'll get this as root 2 by 8 omega cube C1 C2 L into RL. So by using this equation, we can find out the ripple factor for this pi filter. So these are the some of the advantages for pi filters. The output voltage is high, ripple factor is low, peak inverse voltage is high, and the disadvantages of pi filter is the voltage regulation is poor, it is large in size or bulky, it is weighty, and even it is expensive since we are using one more capacitor over here. So let us see some of the applications of filters. Filters is used for attenuating noise within the signal as well as power lines. Whatever noise is formed in the signal, that can be reduced in power lines. When there will be when there is any kind of noise, that can be reduced by using filters. These filters are applicable for demodulating the communication signals in the exact frequency range. So this is all about filters. With this, I stop here. Thank you. Thank you so much.